Caloric restriction and fasting are among the most reliably demonstrated inducers of autophagy in the biological literature. The mechanism involves energy status sensing. When cells detect a drop in available nutrients, AMP-activated protein kinase is activated and mechanistic target of rapamycin, the growth-promoting complex that actively suppresses autophagy, is inhibited. The result is cellular cleanup. Autophagy ramps up to recover amino acids and other materials from damaged cellular components, essentially recycling internal resources when external supplies are diminished. This is elegant, well-established biology. The practical problem is that sustained caloric restriction and prolonged fasting carry physiological and social costs that make them impractical as routine lifestyle interventions for most people. This is where leafy greens present a genuinely interesting nutritional argument. A plate loaded with spinach, kale, mustard greens, collards, or Swiss chard provides exceptional concentrations of vitamins A, K, C, and an array of minerals and phytochemicals within a caloric package so small. Roughly 7 to 40 calories per cup depending on preparation. That large volumes of these foods do not meaningfully activate the mTOR growth signaling that suppresses autophagy. The nutrient-to-calorie ratio creates something that researchers have described as a fasting mimetic environment. The cellular abundance of cofactors, antioxidants, and metabolic supporters needed for autophagy machinery is maintained, while the low caloric and low amino acid density from plant sources avoids the mTOR stimulation that would shut autophagy down. The nitrate content of leafy greens adds a vascular dimension to this picture. Spinach, arugula, and Swiss chard are among the highest dietary sources of inorganic nitrate, which gut bacteria and salivary glands convert to nitric oxide, a molecule with documented vasodilatory properties and autophagy-promoting effects in vascular endothelial cells. Increasing dietary nitrate through leafy greens has been associated in controlled trials with measurable reductions in blood pressure and improvements in endothelial function, effects that likely involve autophagy-dependent removal of dysfunctional endothelial components alongside direct nitric oxide signaling. The preparation strategy matters for preserving the vitamin content that drives these benefits. Raw massaged kale retains more vitamin C than cooked kale because the heat-label vitamin degrades rapidly even with light steaming. Spinach, by contrast, releases more bioavailable calcium, iron, and beta-carotene when lightly cooked because heat disrupts the oxalate mineral binding that limits raw spinach's mineral contribution. The practical approach is to include both raw and lightly cooked leafy greens across the week rather than committing to one preparation method universally. The timing consideration that emerges from the mTOR autophagy literature is worth noting for those interested in optimizing the autophagy signal. Consuming leafy greens before protein-rich meals rather than after may produce a brief period of reduced mTOR activity as the green-dominant meal is processed before the subsequent amino acid influx from protein activates growth signaling. This is mechanistically reasonable rather than clinically proven in humans, but it represents a practical eating sequence that costs nothing to implement and aligns with autophagy biology. The oxalate caveat for kidney stone formers applies to high-volume spinach consumption specifically. Rotating among different leafy varieties distributes the oxalate load and maintains nutritional diversity.